Hello, I'm Chavis from Bradford. This is our first video together. I'm kind of interviewing her because she had to correct me on a lot of stuff that I got wrong. Because honestly, I know more about experimental physics, but her mind is more deeper and richer when it comes to mathematical structures. So I'm gonna talk about some experimental physics first. Basically, I'll be using apparatuses to test various hypotheses, but they will be refined by her. And some of the things that we'll be using, and I will admit, there are cue cards in this because she didn't want it to be just spontaneous and an impromptu thing. So I'm going to admit that and get ahead of the story before someone says, well, you're reading off something. Yes, I am. Interferometry bolometers, which was used in WMAP in the Planck Space Observatory, scintillators, gyroscopes, which were used in Gravity Probe B. Some more immediate things that are coming up will be muon detectors. We're going to be putting one of those on a weather balloon and using MATLAB to kind of refine our findings. Radio astronomy may be done, but that probably will be in the further future. And we will have to use oscilloscopes, function generators, and soldering guns to kind of refine what we're going to do with this muon detector, because you have to have certain transistors and diodes and things of that sort for the computational aspects to work correctly. And we've also found online fiber optics microsync interferometer for, it says $297, but plus tax it'll probably be like $310. And that will be used to analyze interference patterns. Now that I've said all the easy stuff, I'm going to ask her some questions. Okay. Now, what are some of the things that you're going to probably have to do when it comes to computational physics and mathematical physics? What are some of the things that you think you might have to do in comparison to experimental physics?
Well, for example, first of all, I'm interested in topology, and topology defies all forms of experimental data at the moment because it deals with warping and manipulating materials, or even metamaterials, if you want to think about that. Second is the degree in which you can use abstract algebra in mostly theoretical physics, such as quantum chromodynamics and stuff. Like, okay, with abstract algebra, that's the basis in which historically Bertrand Russell and Ludwig Wittgenstein used it for proving logical axioms. However, in this day and age, in 2019, we are no longer as, I guess, unempirical. We're using this science and mathematics for a more empirical sense. So abstract algebra can be used in vectors, fields, and even mapping out scalars of certain particles, like even bosons in some cases. Very rare though. Another thing is Monte Carlo methods for physics and mathematics. The difference between Monte Carlo algorithms and methods is that the algorithm usually accounts for speciation in a bad sense. I know bad is too anthropocentric of a word to use, but I really mean variables that you don't account for. Whilst in physics, we are not really that pessimistic, neither are we optimistic, we're empirical. So we use these methods to randomize variables that can't really be mapped down in a linear sense, so that we can make sense out of them. And lastly, I'll be using Bayes' rule and inference and other forms of axiomatic basis to test hypotheses that have been proposed. And that's literally the basis of what being a theoretical physicist means. You can't just put out hypothesis with no basis for it. You do eventually need to test it where he comes in.
Wow, kind of impressed, very impressed with that answer. What do you find the most interesting about physics and mathematics?
The most interesting thing about physics and mathematics, I know this may be a bit, I guess, commonplace to say, but I think the most interesting thing is deducing natural phenomena. And by natural, I don't mean in an anthropocentric sense. I really mean stuff that occur by means of axiomatic and empirical basis. Basically reducing it and trying to understand what it means, that's the most interesting thing. Yeah.
Okay, just to kind of bounce some axioms and syllogisms off of you, a lot of people say natural, it's a dubious metaphysical meaning behind it for some reason, and you're meaning natural in the sense of our physical, chemical, and biological, even though we're doing more physical and chemical things.
Yes.
You mean it in that sense, not
by material that the Higgs boson produced.
Yes,
Like
yes. Fermions and things like that, quarks and leptons. Now, this is something, I wouldn't say it's anthropocentric, but because we're people, we have to kind of analyze.
We're not AI yet, are we?
We're not AI yet. We're not cyborgs yet. But people are curious about things on the order of magnitude, on the institutions and the educations. Now, we both know that how these things will be fixed would have to be something a lot deeper than just switching a teacher around. It's neurological. But how it emerges itself into neurology on the order of magnitude of the institution. Tell me about secondary school. Did it fulfill your with needs or obligations when it comes to understanding physics and mathematics?
Well, here's the way it's set up in most societies. The degree of which they want you to learn physics and mathematics is for a more industrial sense, so that you can, I guess, give back to the economy in which you suck up of, because everybody's existence is tied to money. So in that sense, since I wanted to probe more about physics and mathematics in a deeper sense, in the way a physicist and a mathematician should, rather than a worker be, it did not fulfill me in any way possible. In fact, when I would ask questions about, for example, the cosine rule, why it happens, what kind of derivation, what kind of methods are used to derive it, or even the quadratic formula, you have to use the complete the square method to even get the formula, which they didn't actually teach in my school. And when I asked questions about it, they would tell me to stop thinking so much.
Wow, they tell you to stop thinking so much?
Yeah.
That's what they told you as teachers?
Yes.
And that's...
I mean, they're not meant... I know I'm going a bit existential, but they're not there to teach. They're there to do their job.
They're there to do their job. That's very interesting. So, you weren't really getting the information you needed there. They weren't really telling you about the cosine rule or all these things that are needed in, pre-calculus and post-algebraic equations. So, tell me, you went to the 90 Years of Quantum Mechanics lecture. I think Mukhanov was there. Tahoeft was there. One of my favorite physicists, James Hartle, was there. Who he worked with Thomas Hertog and what was his name? Hawking on the no boundary proposal. And you got to see all these people in real life, but you had actually, and we can say this now because you've graduated, you skipped school to go to a postgraduate lecture. Is this correct?
Yes, in fact, my English teacher contacted me and said, "Why aren't you in school? You have to learn English." Yes.
Wow. I mean, that's... this is my wife, by the way. She's no longer my fiance. This is my wife. We're married and everything. So, I mean, that's rare. I don't usually see that, and that was someone sneezing in the background. We're going to leave that because that's biology right there. We're going to leave that in here. But you rarely see that. You rarely see things like that where people are actually skipping secondary schools to go to a postgraduate lecture. Now, who was your favorite speaker at the 90 Years of Quantum Mechanics lecture at Nanyang Technological University?
Gerard Tahoeft was my favorite, mostly because it was very interesting the way they introduced him onto the stage, because for most other physicists, they would just read out their thesis and their name and just let them go out. But before reading out his name and his thesis, they said something, I can't quote exactly, but they said something alluding to, this man is here to break your preconceived notions and is here to propose something that most people would not adhere to, which at that time was slightly referring to the Copenhagen interpretation. So he came on there and he initially was going to talk about black holes, but I guess to people's demand, because they view him as more of an iconoclastic physicist rather than, a typical physicist.
Mm-hmm.
He was then invited to talk about his cellular automaton interpretation of quantum mechanics, which is very different from the Copenhagen interpretation. It deals with superdeterminism and how it's sort of like a mechanical procession of different variables and how they intertwine to eventually go to the scale of, I guess, from quantum to cosmological.
So you don't adhere to the... Because Niels Bohr, he really convinced a lot of people, and even the dogma still exists today that the collapse of the wave function emerges into a certain type of indeterminism in which we can't know, or we will never know about certain things about the wave function or probabilities in quantum mechanics. So you and 't Hooft, and I don't know where I stand with this yet, because I don't be honest, I'm an experimental physicist and this stuff is a lot more intense. Perhaps the data I would use would refine whatever they're talking about, but you don't adhere to the notion that of the purely, indeterminate universe.
I mean, what I can say is it is correct in the sense that I do not adhere to the Copenhagen interpretation in any way, form, sight, smell possible, although you can't really smell particles at that level. But I can't really say I'm fully fledged a superdeterminist either, because if you look up the paper in which they wrote, it's from 2014. And we're all still waiting for the second version of the paper for more mathematical, I guess, deductions. So in that sense, I would say I wouldn't proclaim and say I am a superdeterminist right now. I am kind of in between. But I would lean more to superdeterminism than the Copenhagen interpretation.
That's very interesting. Sean Carroll, he adheres
to emergence.
He's into emergence and the many worlds interpretation with Hugh Everett. You also have Bohm's interpretation of quantum mechanics, in which the particle is on this kind of wave that's still deterministic. It's on a wave that's going towards that makes the interference in the two-slit experiment, double-slit experiment. So that's actually very compelling. That's all very compelling, and this is coming from someone who really has immigrated elsewhere to kind of pursue a lot of different things. Now, Singapore is this is where you're originally from. We saw some amazing lectures there. We also, me and you, we both went to the lecture on dark matter, in which Lars Brink was there. There were a lot of other physicists there. Michael Tobar, he's a kind of obscure experimental physicist from Australia. I think he was using some type of electromagnetic pulse to detect certain types of dark matter. It was more, that lecture was more experimental. So you like the 90 years of quantum mechanics better, didn't you? Yes. Because it was a lot of, there was people using all these scintillators and neutrino detectors underground. But the highlight of that lecture was actually we both got to see a Nobel laureate. Now, so you've seen 2 Nobel laureates.
Well, in the first quantum mechanics one, there was also another one.
Oh, who?
Mr. Warse, I don't remember his first name, but he won the Nobel Prize in chemistry.
Oh,
So,
that's interesting. So 3. I've only got
I can't logically say it without confirming it
Yes.
right now.
It's, since we're done with the scripts, it's here. This this is a book that she brought back on it. The only one I've seen is Frank Wilczek. He won a Nobel Prize when it comes to quantum chromodynamics.
If you're going based off of this graph, it would be 6.
Oh, wow.
Because all of them have
Ah,
Nobel
yes.
Prize,
He did. He
including
won.
Nyang.
Cheng, yes, he did when it comes to, actually, when it comes to this book right here. Now, this book is is very advanced. I'm honestly I haven't read it all yet. To be honest, it's a postgraduate book, but, the preface is at the beginning of Yang's Mills theory when it comes to quantum chromodynamics. And I'm at the part where Wolfgang Pauli, I'm not sure if he's angry with Oscar Klein or Yang himself, but he's interrupting one of their lectures because when it comes to quantum chromodynamics, it's not like electromagnetism or gravity in which the field is going outside of a certain threshold. Quantum chromodynamics usually stays within the gluons and the quarks. It's usually within there's quark confinement. So he was upset because he thought that these Yang-Mills theories were making it where they would extend beyond that. But yes, we've got to read all of that. This is another book that we got from the Dark Matter conference. This is more of her book than mine because she's going to have to use MATLAB. And yeah, so that's going to be more of hers. But then again, I'll have to study it too because I have to know how to set up the experiments based off of a lot of her data. Another book, Fantastic Realities by Frank Wilczek. It's, I'll say out of all the books, I say it's the most interesting. That's when I read stuff like that, I kind of think humanity is not all just crap. Because he's not very robotic in the book.
He's quite engaging.
He's very engaging and he's very creative. And that's one of the, and I'm not going to get too existential here, I do think there's some aspects of humanity that are a grave threat to intellectualism and things like that. But he fosters his creativity in a way that's actually quite compelling and not dubious at all. So that's actually, out of the books, that's probably my favorite as of right now. Now, one last thing I'm going to talk about with you is a lot of people have this notion that in high school, there's these memes floating around like, well, cosine trigonomic functions didn't teach me how to balance a checkbook, and all these higher pre-calculus things, they didn't teach me how to do real estate or how to buy a house or how to be a parent. And this makes it where a lot of people don't think the ACT and the SAT, and in Singapore, the A levels, because a lot of people take the O levels, but we can get into that later. But what is the importance of these pre-college exams, and how they can be important for humanity in your personal life?
Well, they're important. Well, first of all, let's deal with the question of these mathematical topics are not going to be used in reality. The truth is, these kids, I would assume, probably are kind of myopic in their worldview, in the sense that they think everything around them is what encompasses reality. Well, the truth is, if you look up to many professions, even underwater diving as a profession, you need trigonometry to locate where they are, or else they might die underwater.
That's true.
If you're not tracking them. Even to fly on a plane, you need trigonometry. And the higher up, the more... Everyone wants to be a lawyer or a doctor because it gives you money, but the real question is, why does it entail more money? It's because you have to do more mathematics in it. Even for medical professions, you need statistics to map out the probability of certain diseases and stuff. So that's one thing. Another thing is the reason why these exams are important. Most people view these exams as just exams. They're just exams for stress. They're just there for some institutional reason. The real gist of it lies in the curriculum and the material that you're supposed to study. These are important as they force you to think critically. They force you to... If you're actually studying, right? Most people do not study, right? They do rote retention, rote memory. The real... I don't want to get into epistemology, but truth values and stuff of information, you're supposed to create a web and know more based on what you already know. So in that sense, going higher up in these exams will give you more challenging curriculum, which by rights will give you more sense of what reality is, because reality is more complex than we all think it is at the moment. And even as a baseline, you should be more informed of things around the world.
Wow, she honestly blew me away with this. I'm not gonna lie, I'm kind of in awe here. It went on for almost 20 minutes, but this, it didn't seem like it. It seemed like this was only a few minutes long, but it was so encompassing and engrossing that it went on for that long. So, yep, we got to get back to our menial adulting lives so we can get to the point where we can do all this other kind of stuff. But hopefully this, gets you to want to pursue the ACT, the SAT, the O levels, the A levels, and the MCAT and the GRE after that point. And that's all we got to say for now. Goodbye.